Alright, so, very first lesson, and again, I think everybody could fly through this worksheet, but I actually want to teach it this way to establish what we're going to do in the future when we get to much harder problems. These are one-step solving algebra equation problems. So here we go, very first one. And again, you may be able to do this in your head where you go, x is 7, I'm done, I got it, let me just put that answer. I'm trying to establish a pattern here, then we get to much harder problems. This is a huge aspect of college algebra, solving equations. We're going to get to much more difficult ones than this. I want you to follow this procedure because you are going to get stuck at some point, and you need a repetitive procedure to do this. So even if you've got half these answers already done, draw a line down from the equal sign on that problem and circle X. I know this seems simple, but this establishes the foundation that if you can do it here, we can get to much more difficult problems in the future. Alright, now analyze. What is happening to X? It's being subtracted by 2. This is going to be our approach to all of this, consistently. I have to establish in my mind what's happening to X as it's being subtracted, and then I'm going to say this word a whole bunch. We're going to undo that. We're going to do the exact opposite to it. So what is the opposite of subtraction? Addition. So to undo subtracting by 2, I'm going to add by 2. If I do that to one side, I must do it to the opposite side. Everything that I said right there, you guys are going, I already know this. This is basic. I understand this. But we're going to apply this to situations like this. When it's x minus 2 quantity squared equals 16, or where it's x squared minus 2 equals 16. These two problems here give a lot of people they go, I'm not sure what to do on some of these, and I don't know why this is different from this one, and why we take steps out of order. Again, this is why I'm establishing it this way. If you can follow what I'm saying here and do it like this, then everyone will have a 100% success rate, and when we get to these problems, there'll be no problem. Okay? It'll be very easy for you. Again, that's where we're going. Alright, so with this, x comes down, minus 2 plus 2 is 0. You don't have to write the 0, but that's why we did that. And again, this is huge that I need to just continually say why we're doing something. Not just I can follow the procedure here, but why. Minus 2 plus 2 is 0. It's gone. My goal was to get x by itself, and 5 plus 2 is 7. Alright, now the little fun aspect of this is why we're starting with this on the first day, is now x equals 7. Wherever you can find a box that has a 7 in it, you need to color it that way right there. Somebody back there, you know what I mean. So right here in the middle, there's a box that's 7. I just colored it in the exact same way. Now there are more than one boxes that have 7 in them. Down in the bottom right corner, there's a 7. You can color it in that way. Thank you. I think that is it. Any other 7s? No, that's it. Just those 2. And you can, if you want, you can do all the work, and then you can come back and color them in the end. It'll be absolutely fine. Alright, let's go to the ones that throw people for a loop. Oh, let's go to right down here. The x over 3 equals 6. For some reason, division seems to be that kind of, at times, it just throws students off. Again, every single time, draw a line, analyze what is happening to x, and then undo it. So what is that 3 actually doing to x? It's dividing. What's the opposite of division? So I'm going to multiply by 3, and I'm going to multiply by 3. Now, it's not that I multiply by 3 and I get 0. What is 3 divided by 3? Yeah, it's 1. So again, I just want to make sure. I know this is simple stuff. I'm not teaching a lot here, but I want to draw the connection. We undid subtraction with addition that gave us 0. X plus 0 is just x. Down here, I'm undoing division with multiplication. 3 divided by 3 is 1. Well, how I could write that is 1x. But if it's just 1x, you don't have to write the 1. It's just x. Like right here, x plus 0 is just x. There was no reason to write plus 0. Now you can, it's not wrong, but I'm trying to get x by itself. 1x is the same as just x. And 6 times 3 is 18. So now there's any box with an 18 in it, I color that way. So there's an 18 in the top. There's a bunch of them here. There's an 18 up here, so I'm going to color it that way. There's an 18 over here on the right top. I'll color it that way. There's an 18 in the bottom here, color it that way.
So what's the point of coloring it in?
You're gonna get a little design in the end. That's just the kinda, hey, welcome back to school, let's do some coloring activity. Just kidding. Oh, and there's two 18s here. They're all over the place. See how much fun I'm having by coloring. Alright. In the end, you will get a design, a pattern, a little geometric pattern there. Alright, you wanna see any others? Anyone confuse you for some reason? Let's just go with the 3x and the 15. Doesn't matter what side x is on. I mean, it absolutely does not matter. X is on the right side, that's fine. I'm gonna undo the multiplying by 3, and I'm gonna divide both sides by 3. When I get a 15 divided by 3, I get a 5. And a 3 divided by 3, again, it's not 0. 3 divided by 3 is 1. It's 1. If it was 0 x's, I wouldn't have any x's. But 3 divided by 3 is 1x. Alright, so anywhere there's a 5, I'll color like that. You get the picture. That's what I'd like to see. I do actually want to see a little bit of work there. I know you can do most of this in your head. But if you can write that, it establishes getting to a harder place. This is what we're doing on the first day. Let's start off with the right foundation so we can build on it.